Now we're going to take a look at inventory management. As you saw in the textbook, maintaining inventory is a terribly expensive proposition, and why firms try not to keep any more inventory than they absolutely have to. But by the same token, we've all shopped places where they never have what you want. So there's this constant balancing act that takes place between having the right things on the shelves in the right amounts and not having more inventory than you absolutely need. So what we've done in this chapter is to give you what we call the very basic inventory models. If you want to get more involved in this, they can make them really complicated with all sorts of probabilities and demand estimations and so on and so forth. But our objective with the problems we had here was to at least make you aware of the trade-offs that occur and see sort of how these things work, and we do that through our basic model. Once again, we're back to Atherton Foods, and we're looking for a better way to manage inventory. The first item they want to examine, it sells for $1.28 per unit. The inventory cost us about 25% of the average value of the inventory. So what that means is during the year we have a general idea how much inventory we have, how much that inventory is worth, and on average the cost of counting it, weighing it, securing it, insuring it, and all the other stuff that goes with it typically runs about 25% of whatever that value. So if we had $100,000 worth of inventory, if we had $100,000 of the inventory, it cost us $25,000 a year on average to maintain that inventory. If during that average year we use 72,000 of these units, and each time we place an order, our industrial designer guys tell us it costs about $20 of staff time and assorted other hoopla to place an order for more of it. And we also know that once we've placed an order, it takes 5 days from the time we place that order till we see the truck backing up outside and we get replenished. Now, in all the examples we do in this course and others, we just assume the year has 360 days. Makes life a lot simpler. It will work with 365 or the number of work days, whatever you would like. Let's start. If they wish to minimize the total cost of their inventory for this item, how many should they order each time? This how many I should order each time is the economic order quantity, EOQ. And if you look at the stuff in the book, you can see it's the lowest total cost, balancing off ordering cost and carrying cost. I'll refer you to the book for some of the background. So in this case, we just have the general equation. Economic order quantity is the square root, and I couldn't find the square root sign, so we're just going to tell you it's the square root, and times 2RS over PC. All right, what does that mean? 2 comes with the general equation, and we derive it in the book. R stands for the annual requirement. That's the 72,000. The S is the cost of placing the order. That is the numerator. In the denominator, we have price times C, which is the carrying cost. This is the one that's interesting. When we insert the numbers, it's pretty simple. 2 times 72,000 times 20, there's our numerator. The price is $1.28, that's simple. The biggest problem when people mess up is the carrying cost percentage has to go in as 0.25. If you enter 25, you're not going to get an answer that works. And since I work all these from the answers backwards, anytime you get an order, some screwball number or a repeating number like 999 or 777, you messed up, and this is the most likely place that you've done that. After that, it's pretty straightforward. So we end up with 2,880,000 divided by 32. You end up with 9 million. We take the square root of the 9 million, and the economic order quantity is 3,000. How do we interpret that? It says each time we buy stuff, the order is for 3,000 units. At 3,000 units per order, we're going to minimize the total cost, balancing ordering cost and carrying cost. And if you've seen the stuff in the book, it shows you for each $1,000 or whatever you can take out of inventory, it's like a huge increase in sales. The second part of this is, when do I place my order for the next group of 3,000? And we call this the reorder point. And again, it's something you can figure it out pretty quickly on your own. R being the annual requirements, divided by 360 days, which means that's how many we use, 200 a day. And since we use 200 a day and we have to wait 5 days, that when we have 1,000 items left in the bin, it's time for us to reorder. Back in the dark ages when inventory was much more simple, a lot of firms had 2 bins where they put stuff, and when they finally emptied out the big bin and broke the brown paper on the smaller bin, you would take that card up to the guy in the front of the inventory area, and that would tell him that you were down to the point where it was time to reorder. Very simple, very straightforward. Here's the last one. And I know it's nowhere in the course that I promised that you wouldn't be allowed to think. Well, this one is not in the book, but I will often be on the test. So if you're good enough to get this far, you'll do fine. If they buy the EOQ number of 3,000, and if they use 72,000, about how many orders will they place each year? This is in the book, but can be readily calculated by R over EOQ. In our case, 72,000 by 3. That's 24 orders. About every 2 weeks, you'll be placing an order. So there you go. A quick look at inventory. There are entire courses that you can spend looking at all the details and trade-offs and so on and so forth. Many people that think the supply chain management, which started out as better inventory management throughout the system, has been a big factor in our economic success. I encourage you to look closer at this, but don't overlook inventory as the place to increase your profits.